Okay, as a beginning, for calculations, at the beginning, we must know the difference between atom, ion, and isotopes. Atom is neutral, as we know, because the number of positive charge protons equal number of negative charge electrons. So protons equal electrons, or positive equal to negative. Like, for example, if we have Na11, protons equal 11, electrons equal 11. In case of Cl17, protons equal 17, electrons equal 17. Ion is a charged atom. What is meant by charged atom? Atom after losing or gaining electrons. And we have, and the protons not equal to electrons. We have positive ion and negative ion. In case of positive ion, protons is greater than electron because it's losing electrons. While in case of negative ion, gain electrons, and electrons greater than proton. Like, for example, if you have Na positive, protons equal 11, electrons is equal to 10. Negative ion, like Cl negative, protons equal 17, electron is equal to 18. After that, isotopes, atoms of the same element. With same number of protons and different number of neutrons, or same atomic number and different mass number. And you find that protons equal protons, electrons equal electrons, but neutrons not equal to neutrons. Like, for example, if you have carbon C612, C613, and C614. Protons for all equal electrons equal 6, but neutrons equal 6, 7, 8. And for that reason, you'll find that protons equal protons, electrons equal electrons, but neutrons not equal to neutrons. In isotopes, you will find that they are same element, and they have similar chemical properties. Explain why for each of the following. They are same element because they have same number of protons, and similar chemical properties because they have same number of electrons in the outer shell. After that, how we calculate the relative atomic mass? Relative atomic mass is the average atomic masses compared to carbon-12. Like, for example, if you have Cl1735, Cl1737, the abundance 70% and the abundance 30%. Calculate the relative atomic mass. Relative atomic mass is the average atomic masses. So we have mass number multiply its abundance plus the other mass number multiply its abundance over total abundance. So it will be 35 multiplied by 70 plus 37 multiplied by 30 over total abundance 100. And you will find that the numbers that will be present is between both numbers 35 and 37. And in this case 35, you can make a calculator now. 35 multiplied by 70 plus 37 multiplied by 30 over 100. Okay. So again, relative atomic mass is the average atomic masses compared to carbon-12. In case of Cl1735, 70%, and Cl1737, 30%. Calculate the relative atomic mass. Relative atomic mass is the molar mass multiplied by its abundance plus other mass number multiplied by its abundance over total abundance. And you will find that the number in between. The number in between يعني عندي هنا 35 و 37 هلاقي النمبر اللي هنا هيطلع in between هلاقي مثلا يطلع 35.6 in between the number two numbers. After that, calculations, moles, number of moles. How to calculate the number of moles? Number of moles is equal to mass over molar mass in case of solid equal concentration multiply volume decimeter cubed in case of liquid equal volume decimeter cubed over 24 in case of gas at RTP equal volume decimeter cubed over 22.4 in case of gas at STP equal number of molecules over Avogadro's number. Again, number of moles is equal to mass over molar mass equal in case of solid equal concentration multiply volume decimeter cubed in case of liquid equal volume decimeter cubed over 24 in case of gas at RTP volume decimeter cubed over 22.4 in case of gas at STP. Also equal number of molecules over Avogadro's number. How can I know which one I use? In case of mass over molar mass, this is for solid. The mass must be known from the unit will be gram, kilogram, or ton. For the volume, centimeter cubed, milliliter, decimeter cubed, or liter. Concentration, molar, or mole per decimeter cubed, or gram per decimeter cubed. Particles, or molecules, or atoms, or ions. For example, calculate the number of moles for each of the following. Number one, 23 grams of sodium, knowing that Na equal 23. Calculate the number of moles of 500 centimeter cubed HCl, 0.5 mole per decimeter cubed. Calculate the number of moles and 48 decimeter cubed of oxygen gas at STP and at RTP. Calculate number of atoms and 3.01 times 10 power 23 sodium In each case it depends on the givens. يعني ايه؟ يعني هبص هنا على الجيفنز اللي عندي. Mass over molar mass. How can we know this mass? Gram, kilogram, tons يبقى mass. طيب concentration and volume. In case of concentration mole decimeter cubed, volume centimeter cubed, milliliter, decimeter cubed and liter. طبعا احنا بنستخدم الفوليوم بالديسيمتر كيوبد. فإن case of centimeter cubed equal milliliter over 1000 to be decimeter cubed, and decimeter cubed equal liter. Okay, يبقى it depends on the units. أول واحدة هنا هقول إيه؟ Number of moles is equal to gram يعني عندي mass. Mass over molar mass equal هاخد 23 over لقيت هنا 23 equal 1 mole. Number 2, 500 centimeter cubed volume, 0.5 mole decimeter cubed concentration. يبقى هنا number of moles equal concentration multiply volume decimeter cubed equal 500 over 1000 multiplied by 0.5. Number 3. Okay. Number of moles, 48 decimeter cubed of oxygen at S3 and R2B. Number of moles is equal to volume decimeter cubed over 24 and volume decimeter cubed over 22.4. It depends on at STB or RTB. RTB, so it is 24. At RTB, STB 22.4. Number of atoms, so number of moles is equal to number of atoms over Avogadro's number, 6.02 times 10 power 23. So it will be 3.01 times 10 power 23 over 6.32 times 10 power 23, 0.5 mole. Okay. After that, more ratios. For example, if we have C2H5OH plus 3O2 gives 2CO2 plus 3H2O. And then if we have 23 grams of ethanol, calculate the mass of carbon dioxide, calculate number of molecules, number of atoms, and concentration if you have volume 500 centimeter cubed. In any more ratios, we have 3 steps. Number 1, to calculate number of moles. Number 2, to calculate the mole ratio. Number 3, use the new moles. Okay, number 1, calculate the number of moles. We have 23 grams. Grams, this means that we have a mass. So number of moles of ethanol, C2H5OH, is equal to mass over molar mass. Is equal to the molar mass of ethanol, C2H5OH, from periodic table, C equal 12 times 2 plus H equal 1 multiplied by 5 plus 16 plus 1 equal 46 grams. So number of moles of ethanol, C2H5OH, is equal to mass, which is 23, over molar mass 46 is equal to 0.5 mole. Okay, this is number 1. يبقى أنا بدأت أحسب أول حاجة إيه؟ النمبر of moles. خدت الماس over molar mass. Number 2, mole ratios. Mole ratios. 1 mole is reacted with 2 moles. So the number of moles of carbon dioxide is equal to 0.5 multiplied by 2 equal 1 mole. بس دي number 2. انت كده جبت اول حاجه number of moles. number 2 mole ratios. اهي number of moles mass over molar mass. number 2 mole ratio. number 3 to get the mass. لما ارجع هنا للفورمولاز اللي انا عاملها دي number of moles multiplied by molar mass to get the mass. Number of moles multiplied by Avogadro's number to get number of molecules. Number of moles multiplied by 24 to get volume decimeter cubed at RTP. Number of moles multiplied 22.4 to get volume decimeter cubed. Over concentration to get volume, over volume to get concentration. Again, يعني لو أنا معايا number of moles أهو. Number of moles. Number of moles multiplied by molar mass to get the mass. Multiplied Avogadro's 6.02 times 10 power 23 to get number of molecules. Multiplied by 24 to get volume decimeter cubed at RTP. Multiply 22.4 to get volume decimeter cubed at STP. Over concentration to get volume decimeter cubed. Over volume decimeter cubed to get concentration. فدي كده القوانين بتاعت الاستايكومتري كلها المولز اتلخص في حاجتين. انك تبقى عارف النمبر اوف مولز في الاول equal mass over molar mass in case of solid, concentration multiply volume decimeter cubed in case of liquid, or in case of centimeter cubed or milliliter over 1000 to be decimeter cubed. Equal number of molecules over Avogadro's, equal number volume decimeter cubed over 24 gas at RTP, volume decimeter cubed over 22.4 at gas at STP. Type number 2, number of moles multiply molar mass to get the mass, Avogadro's molecules, 24 volume decimeter cubed at RTP, multiply 22.4 volume decimeter cubed at STP over concentration to get volume decimeter cubed over volume decimeter cubed to get concentration. طيب انت جبت هنا ايه؟ اول حاجه number of moles خدنا mass over molar mass. Then mole ratios 1 to 2 جبت new moles. طيب number 3 لو هو بقى محتاج الماس اخد النيو moles اللي عندي ده multiplied by لو انت عاوز هنا نجيب الماس اخد number of moles اللي انا جبتها الجديده واعملها multiply molar mass هجيب الماس. اخد number of moles multiplied by Avogadro's لو انا محتاج الموليكولز. طيب اخد number of moles over الفوليوم بس اخليه decimeter cubed يعني 500 over 1000 يعني احول دي الاول 500 اخليها over 1000 وبعدين اعمل هنا over الفوليوم to get concentration. طب موضوع انه عاوز atoms اخد number of molecules اللي انت جبتها واعملها في number of atoms. يعني ايه؟ يعني هما كربون دايوكسيد. الكربون دايوكسيد هنا يعتبر عندي 3 atoms يعني كنت هعملها multiplied by 3. تاني دي كل الافكار بتاعت المسائل اللي عندي هنا في المول ratios. Mass of ethanol and we need to obtain mass of carbon dioxide or number of molecules or number of atoms or concentration if we have 500 centimeter cubes volume. As a beginning, number of moles, mass over molar mass. Number 2, mole ratios 1 to 2. So the number of moles for ethanol 0.5. Number of moles of carbon dioxide 0.5 multiplied by 2 equal to 1. After that, number of moles multiplied by molar mass to get the mass. Multiplied by Avogadro's number to get molecules. Number of molecules multiply number of atoms to get the atoms. And I the number of molecules in atoms multiplied by 3. To get volume concentration, number of molecules over volume, but the volume must be decimeter cubed فعشان كده عملناها over 1000. طيب دي أول حاجة اللي هي المول ratios. After that, empirical and molecular formula. Empirical formula is the simplest formula. For example, if we have carbon and hydrogen, the mass of carbon is 24 and the mass of hydrogen is 4. Calculate the empirical formula. فباخد هنا الماسز over ال AR periodic table الاقي carbon 12 والhydrogen 1. بعدين number of moles is equal to mass over molar mass 2 and 4. Mole ratios, division of the lowest value over 2 over 2 equal 1 to 2. So the formula CH2. This is the empirical formula. In molecular formula, if we have the molecular mass equals 70, what is the molecular formula? Molecular formula is equal to molecular mass over empirical mass, C equal 12, H1 multiplied by 2, so it equal to 14. 70 over 14 is equal to 5. So it will be 5 multiplied by CH2 is equal to C5H10. This is the molecular formula. So empirical and molecular formula, empirical mass over molar mass, then number of moles, then division of the lowest value to get more ratios. This is the empirical. Molecular formula, if we have the molecular mass equals 70 over empirical mass, CH2, 14, so 70 over 14 equal 5. 5 multiply CH2 equals C5H10. After that, percentage yield equal actual over theoretical multiplied by 100. What is the difference between actual and theoretical? Actual is a given. Theoretical that be calculated. For example, if you have N2 plus 3H2 gives 2NH3. If we have 14 grams of nitrogen and 15 grams of ammonia, what is the percentage yield? Percentage yield is equal to actual over theoretical. Actual is 15. Theoretical that will be calculated now multiplied by 100. Consider 15 as unknown. اعتبر دي كأنها مش موجودة عندك. Then هنعمل الثلاث حاجات اللي اتفقت عليهم. Number 1, number of moles. Number 2, mole ratio. Number 3, use the new moles. Number of moles of nitrogen is equal to mass over molar mass. Mass equal 14. Number of moles of N2 is equal to mass over molar mass. The mass of nitrogen, 14. Molar mass, 14 multiplied by 2. So it equal to 0.5 mole. After that, mole ratio. Mole ratio هنا كام لكام يا شباب؟ Mole ratios equal كام؟
1 to 2.
1 to 2. So the number of moles of ammonia is equal to 0.5 multiplied by 2 is equal 1 mole. Okay. After that, the mass of ammonia NH3 is equal to number of moles multiplied by the molar mass. The molar mass of ammonia N14 and 1 times 3 equals 17. What do you want? So equal 1 multiplied by 17 equal to 17 grams. So percentage yield equal 15 over 17 multiplied by 100. After that, percentage yield equal actual is a given 15 over theoretical supposed to be that be calculated 17 multiplied by 100. So this is the percentage yield. And the percentage yield must be less than 100. So theoretical must be greater than actual anyway.
فراس ملك التظبيط.
Okay. After that, limited and excess. For limited and excess, if we have, for example, N2 plus 3H2 gives 2NH3. Limited and excess. For example, if we have 14 grams and we have 60 grams, which one is limited and which one is excess for the reactants? At the beginning, you must calculate the number of moles for each one. Number of moles of N2 is equal to mass over molar mass. 14 over 28 is equal to 0.5 mole. Number of moles of H2 equal 6 over H2 equal 2, so equal 3 moles. After that, the ratio is 1 to 3. So if we have 0.5 moles, hydrogen must be 1.5 moles. So I have 0.5. And number of moles of hydrogen must be 1.5, not 3. So this means that hydrogen is in excess. Again, limited and excess. In limited and excess, you must calculate number of moles. Number of moles, mass over molar mass, the other number of moles, mass over molar mass, and then mole ratios 1 to 3. The smallest one is 0.5, so it must give 1.5, but we have 3, so this means that H2 is an excess and nitrogen is limited.